Hello everyone, my name is Alexey, and working with DOM using plain vanilla JavaScript is pretty difficult, because you need somehow to track changes of elements inside containers, do it effectively, etc. Today I am going to tell you about Mutation Observer, native instrument which helps developers to deal with DOM mutations. Moreover, this instrument is used by React and Angular for tracking changes in DOM effectively. This knowledge is pretty unique and you definitely need to acquire with it. Okay, no other words, let's start. And a few words about if you want to follow me throughout the video, I want to talk about what I have prepared. So, I've prepared HTML document, so it's just HTML document with added styling, with added index.js, and main block with section, and inside this section I have 3 divs, it's 3 squares, and also empty JavaScript file for now, and also styled blocks. You can repeat this style, so you can pause the video and repeat the style and proceed to the practice about Mutation Observer. Okay, let's create our Mutation Observer. So const Mutation Observer equals to new Mutation Observer. And as an argument, we need to pass here a function. This function will be triggered when some mutation will be occurred according to our conditions. And let's pass here a function. And this function will take changes. So firstly, let's just take it and log. So changes and log our changes. Cool. Then we need to observe some changes on some element. So I propose to start with parent, so parent of these squares, and let's get it by ID. So const parent element equals to document get element by ID, and we need to pass here square element. Cool. Then we need to call observe method on our Mutation Observer. So Mutation Observer, observe, and here we need to pass 2 parameters. First parameter will be node, so it's parent element. And then we will need to pass an object with options. So here we need to change options for us, and it could be child list, attribute filter, subtree, etc. So we will experiment with them further in the video. But for now, we need to pass child list. Child list true, cool. And what this means? This means that Mutation Observer will observe all changes in the child list of the parent element. So if we will have parent element, if item 1, item 2, item 3 will be added or removed, we will trigger our callback function. And let's just experiment with it. So for example, we will have parent element, children. Let's take first element and remove it. Cool. So we removed our first element. And what we have in our console? We have a mutation record. And this mutation record came from console log changes, because this callback was triggered. And what we have here? We have here array of mutation records, and mutation records is basically an object. And let's try to understand what we have in this object more deeply. Okay, let's see what we have here. And the first thing that I need to mention is type. So we have type child list, and we have child list in our options. So type property displays us related to which option mutation was triggered. Second important thing is target. So we have target square parent. So because we observed event on parents, so we can observe multiple mutations on different elements, and it could be valid. So for one Mutation Observer, we can observe mutations on multiple elements. Yes, and the next thing it's added nodes and removed nodes. So if we will remove or add nodes for example, our child list, this mutation record will this display to us. So for example, we can add node, for example, parent append child. and it will be document create element div, just empty div. And we will have empty div and two mutation records. So first mutation record will be about removing our first node, and then we will push append child to our parent element. So it will be second mutation. And as we can see, so added nodes div, and it's our div, so we can hover on it and it will be displayed on our page. And removed nodes is empty node list, and the first mutation, we have one node in our removed nodes, so we can somehow to take some information from this node and maybe do specific manipulations with them. Cool. So now you may ask me, okay, Alexei, why we have here two mutation records? Why we don't have two arrays? Because our function could be triggered two times, and we maybe need to have two separate arrays with one mutation record and second mutation record. And I want to explain this thing. So every time the document or page will change the content and will be repainted, Mutation Observer will collect all updates related to one repaint. So browser is smart and collecting some updates in one to reduce repaint job and increase performance. So this Mutation Observer will collect all changes related to one repaint and will add them to one array and show us this array. So we have here for this console log two mutation records. And it's interesting thing that if we will use, for example, set timeout, and we can provide here our second operation, so about append child, and we can pass it here and, for example, make a delay for 100 milliseconds. And we will have two mutation records because we updated our page two times and we repainted our page two times. So we have one mutation record about removing our first element, yes, removed nodes, and the second mutation record about adding child list, it's div. We've added div to the end of our parent. So how it works, and this is an explanation, one of the peculiarities of Mutation Observer. And once more, I want to tell you about Mutation Observer and its disconnect method. So MutationObserver.disconnect. So it's pretty important method. It's disconnecting your Mutation Observer from the whole stream and like kills your Mutation Observer. So if you are observing some element and you don't need to observe it any more time, please use this disconnect method. You will not have any memory leaks in your application, and this increase performance of your website, web app. So as we can see, no mutation records in our console because we started observing our parent element and then instantly disconnected. So this changes about removing and edit element was not recorded to our Mutation Observer because we disconnected. And this is one mini point, but very important point I need to say, and please remember about it and remember about preventing memory leaks in your application. Amazing. And previously we discovered how we can observe changes on the child list of a specific element in the DOM. And now I want to show you other options. So let's start with parent element, and I am taking this parent element through query selector and I am getting it through class. So this section has class parent. And instead of child list, I want to set here attributes to true. And using this option, we can observe changes in attributes of a specific element. And as we can see in our layout, we have an ID. So section has ID and initial value is square parent. And let's try to change this ID and let's see what will happen. So parent element ID equals to new ID. So it will be string. Cool. And in our console, we can observe array with one element. And in this object, you can see type attributes. So this mutation came from the change of attributes. So we added here flag attributes. And we are observing attributes change. And we can see new target with new ID, it's our parent. And also we can see attribute name. We changed an ID of our element, and attribute name is ID because ID was changed. So next we have here attribute namespace and next sibling, so we don't care about it for now. But interesting thing about old value. You may ask, so Alexei, and why old value is null, but initially ID was square parent, not null. But here we can see null, and I will explain you. And the main reason for this behavior is performance. So observing old value, so getting old value, not only new, is additional computations, and the Mutation Observer doesn't want to do it initially. It will do it by request, and you can say to Mutation Observer, okay dude, please observe attributes and also give to me old value of a specific attribute if it will be changed. So you can pass here attribute old value property and also set it to true. And let's save our code, and inside the console we will see old value. So new value of attribute is new ID, target section new ID. And old value is square parent because initially in our HTML page I set up it to square parent. It's how we can observe old values when we will change some attributes. Also, I want to show you the way how you can increase the performance of your page using one simple option. And this option is attribute filter. With this filter you can just write in the array which attributes you want to observe. For example, it could be ID or data attribute, etc. Because for now, if we will remove this attribute filter, and for example, we will add new attribute data value with value some data, let's save it, and we will have two mutation records. First with new ID, so also type attributes, and the second also from type attributes, it's mutation from attributes, and attribute name, data value was affected. And as we can see in our elements, we will have data value as attribute on our parent element. But for example, we don't want to observe, for example, ID. We want to observe just data value attributes. And we can add attribute filter and just write here in array name of attributes. So for example, it will be data value, and we will have one mutation record. So its mutation records are related to change of data value. If we will add an ID here, we will see also mutation related to change of the ID. And if you will just remove these properties, you will not see any messages in your console because we didn't specify any attributes to observe, and Mutation Observer doesn't care about change of ID or data value because here we passed empty array. Please consider it when you want to observe specific properties. Maybe you should not observe all properties, maybe one or two specific. Amazing. Now I want to show you how you can track change of your node's content, so for example text inside some blocks, using Mutation Observer. So how you can handle the mutations. Interesting thing that we have section parent, and inside we have three squares, and inside this div you can provide content editable attribute, and this interesting attribute which allows you to change the element by your hands. So for example, now I can change the content of the item 1. So just type what I want. Cool. So like if you didn't know this attribute, and now you know. And the next thing I want to pass as options, it's character data. So I can observe character data, so and I can pass through here. And as a target, I will not have parent element. I will have first square. So first square, it's parent element dot children 0, and that's it. So I can type something, but nothing in my console. So why it's not working? And interesting thing that no mutations, because basically following browser's logic, we don't change a div for now. When we are changing the content, we are not changing the div. Pretty confusing, but we change browser's text node. So text node inside div. So yes, confusing, but browsers work in this way. We need to observe text nodes because basically our elements on the page don't have text, they have text nodes. We need to write here not children 0, we need to get child nodes and also get first child node. So first child node for div will be item 1, it will be text node. Yes? Cool. And for now, if we will change our first block, we will have mutations in our console, and it's pretty amazing. So this mutation, for example, was triggered by character data and target was text, as we can see. So all right, and we have our mutation. Interesting thing that also we can provide here character data old value and also set it to true. And now we will track all old values. So for example, I want to change item 1 to item 7, and I have mutation records. So it's really all mutations which I've done, so including backspace, etc. And old value is item 7 for now because I pressed additional space. And interesting thing that we can really write what we want, and we will have mutation records for all our actions, and we will have also old values for all our actions. It's how it works, and it's how you can track changes of content inside your elements. And please remember about the fact that when you are observing content inside some element, you are observing some text node, not an element. Nice. And at last I want to show you one interesting and important property, and it's called subtree. You can pass subtree true for our options. And what this means? This means that we will track all mutations regarding character data and character old value for our parent element, including our parent element. So what this means? If we will pass subtree true, we will have all mutation records for our section, for our divs inside sections, and for text. And if we will have some divs inside our squares, mutations on them also will be recorded. And how it works? So I've passed content editable to item 2, and if I will change item 2, I will have mutation records. If I will change item 1, I will also have mutation records. Cool. And it also works not for character data and basically for attributes. So I can remove this and pass attributes true. And if I will change, for example, ID of my parent element, so parent element ID equals to new ID, I will have mutation record. So I will have my section with new ID. Yes. And also if I will change the ID of one of my divs, so item 1, item 2, or item 3, I can change it. So parent element dot children 0 ID equals to, for example, child 1. Cool. And I will have mutation record also. So I will have type attributes, and I will have target child 1, div with ID child 1. As we can see, ID of first child was changed, and Mutation Observer tracked this mutation. It's how you can track all mutations related to a specific element and how you can handle it without adding observer to every element inside this specific node. Okay, in this video we look at what Mutation Observer is and how to work with it. But look at how we can track changes in our DOM tree, adding and deleting elements. We can track changes in attributes of our elements and also their content. Along with this, we can use the subtree option to keep track of all elements in a particular node. So please like, subscribe, stay tuned, please check the description and follow my Telegram channel and GitHub. Bye.